All right, so it's 1:03. So I guess we can get started. Good afternoon, everyone. I would like to welcome everyone to the webinar today. It is about digital twins and the future of infrastructure. My name is Twin Robert Lay. I am an associate professor at Clemson University in I am the secretary of the ASCE Digital Project Delivery Committee, and I've been helping the committee to organize webinars. So before I introduce the speaker today, I'm gonna let Joseph Thurstar, who is the chair of the committee, to make a brief introduction about the committee. Go ahead, Joseph.
Good afternoon for everyone who is on the East Coast and Central Time Zone, and good morning to those who might be from the West Coast right now. I'm Joseph Shrestha, Associate Professor in Engineering Technology at East Tennessee State University, and just wanted to talk a little bit about this committee before we get started. This committee was formed almost a decade ago, and basically the idea at that time is we in the construction industry has always been lagging in terms of utilizing digital data, in terms of collecting digital data, and in terms of making decisions based on the data we collect. So there was a big need in trying to form a committee and that can do something to improve the situation. And over time, the committee has evolved. I've been in the committee for a while. 2018, I started as a secretary of the committee, and in 2022, I became a chair. And during this transition, uh, during my leadership, we have done a few new things and we continue to do some of the things we did in the past. So one of the regular thing we do as a digital project delivery committee is we organize a session or two at CI Summit, so Construction Institute Summit that happens every year. Next year, it's going to be CI and CRC combined, Construction Research Congress, combined in San Antonio, Texas, from March 18 to 21. So I would like to invite everyone to come to the conference and again, learn from the construction peers, industry professionals, and others on what's happening in the world of digital construction. Now, CI, basically this project, Digital Project Delivery Committee, is a part of the CI or Construction Institute, which is one of the 9 institutes that ASCE has, American Society of Civil Engineers. And the CI's summit next year, in addition to being combined with CRC, it will also be co-located with AEI, Architectural Engineering Institute, and IRD, or Infrastructure Resilience Division within the CI. They are also within ASC. They're also having a conference in the exact same place. So in addition to this, hosting a session every year under my leadership and under um, by contribution from Tuan Lee and Chad Schaefer and everyone in the committee, we started a few new initiatives. One is starting this webinar series. So we want to organize a few webinars so that many industry professionals can benefit without having to come to the conference if they are not able to. We also started a new LinkedIn page, and we can post a link to our LinkedIn page in the chat in a bit, or maybe Twain can post it as we talk about it. And we updated our committee purpose from something that almost sounded archaic. We're talking about, okay, we're going to use digital 2D plans kind of thing to now we're talking about AI and BIM and robotics. So we are evolving as the time pass, and we want to see everyone who are interested in digital project delivery to come and work with us and help us and grow this committee as well as organize sessions like this. With that, Twen, I'll hand it back over to you.
All right, thanks, Joseph. Now I would like to introduce Dr. Aaron Costin, who is the speaker of the webinar today. So Aaron, the mic is yours.
Thank you. Thank you, Thielen and Joseph, for letting me be here today and the rest of the committee. I'm excited to talk about my research. I've been working with digital twins and BIM for about 15 years now. So today the talk's going to be on digital twins in the future of infrastructure. That's a huge topic. And so we're going to try to focus it down as much as we could, and specifically to the integration of the physical and digital worlds for smarter decision making. And so today we'll have about a 30-minute talk with 15-minute question and answers at the end. So some of the topics is we'll go over briefly what the infrastructure challenges are, what is a digital twin and the core enabling technologies around them, some of the life cycle benefits, get into the real world case studies and a roadmap of how to get into digital twin usage. And then finally, we'll go through some of the current challenges and considerations with the final key takeaways. If there are only 4 things you need to know to take away from this lecture is what is a digital twin? What is a digital twin used for now? What could it be used for in the future? And how can I get digital twin technology implemented today? So first, go over the infrastructure. Right, being an ASCE conference webinar, you should all be familiar with the report card that comes up. Right, the assessment every 3 years, and it's greatly has been improving, but it's still an issue of great dire repair, specifically with bridges and major assets like that. There's still some structural deficiencies. It's a major part of the economy, and so we have to determine ways of growing and improving this, right? And so specifically for the surface and transportation needs, there is a $1.2 trillion funding gap to get what the current conditions today, which I believe is around a C, to back to the B and A, right? And that's an imperative process, not just for the transportation industry, but for the economy as whole, right? The report also goes in and estimates a $5 trillion loss in gross economic output over the next 20 years. So it's important to get some of these technologies implemented today so we could start improving our infrastructure, which then in turn will increasingly improve our economy. All right, so why can't we get into that today? Right, so there are budget constraints. There's a lot of competing priorities and short funding cycles, right? There's a gap. So we have to have trade-offs of what assets gets the attention first, which one doesn't. We're also going into climate change and resiliency questions. And so with the given frequency of events, there's a lot more stress, a lot more damage with these events, taking a lot more capital, which would have been used for preventative maintenance. And so there's a lot of issues with the structures themselves. But getting into the technology side of these tools, these also have to adhere to these weather. So sensors can't just be off the shelf placed. They have to be developed in a way that they can survive these harsh environments. And most importantly, with technology, as we've all seen in the vertical world, is the data fragmentation and silos. Right, there's a lot of different tools and technologies. Not about it. The tools and technologies needed to exist to build digital twins today, but the problem is how do we share data across platforms? Right, and so everything lives in siloed data. So it's not necessarily a technology side, but more of an organizational and governance side of how can we utilize these tools today to go ahead and share across the board. And so trying to get to these digital twins is double port, right? We get to fix the infrastructure, in turn improve technologies for those interoperability type issues. So what is a digital twin? Right, we all have our own conceptual minds. There has been debates on what's going on, what a digital twin is, what it's not. The concepts have been around for decades. That the term digital twin has been recently coined, a few decades ago, but the idea is still there. And when I first talk to people who don't understand BIM, don't understand CAD, I show them this picture, or I show them the idea of Iron Man. When Tony Stark gets into Jarvis and he's able to be immersed in all this data, right? He has all these computing powers, all this is, but in essence, what is this? He has a physical asset, which is his suit. He has an AI-backed system, Jarvis, that kind of analyzes all the data. And then he has some type of real-time feedback that says, if he has an incident with the suit, he can report that, right? And so he can get that visual display within that, right? And so even though this may be far-fetched and futuristic, the concepts behind it still stand true of what a digital twin is, right? And then let's go back to the fundamentals. It's based on a living virtual replica of a physical asset, system, or network. Again, depending on your industry or your organization that you work with, those might change, but it still is the same concept of a physical asset, have a virtual replica that you can do things with, right? If in our case, it uses the real-time IoT sensors with historical data, so you can get real-time assets. It helps simulate the what if for prediction and condition risks, and implementing with machine learning and AI, you can actually get recommended actions based on that, which help with decision making. Right? In our context, with the building industry, we're focused on the BIM. We're focused on that beautiful 3D picturesque of that model and how to come to it. But digital twin goes beyond that. It's time aware. It's bi-directional. No, not only do we send the data to the BIM model, that BIM model actually sends data back. It's learning and adaptive. And essentially, the future idea of digital twin is called data immersion. And I can't stress this enough. And if you ever heard me talk before in my research, it's all about data, right? I'm a data scientist. I'm a civil engineer. I do construction, but at heart, it's all about the data, right? And so, how do we unify all these sources to provide insights that you can't see, right? And one of my favorite parts within Iron Man is when he's able to take that and just blow it up. He can see the data. He can be immersed in the data, see some inputs that without this technology would have gone unseen. And so to get there, there's different categories, right? And so the National Institute of Building Sciences, they have a digital twin committee that came out with a white paper about digital twins for a built environment. And they classify it on multiple categories. You have a digital prototype, right? So you do simulation, future connection to the physical environment. That's more so of what we can say as our BIM models or 3D virtual reality models. And then we have a digital shadow, which you have a physical model that puts more information into that, right? So that's embedding sensors in the physical world that can go into the digital twin. But to really get to that data immersion, that real-time conceptual concept of digital twin is a bi-directional flow, where you have the data that goes into your virtual world, it does some analytics calculations, and then it throws back that response that you can now update your physical model. And that is a world where we call cyber physical infrastructures. So to really get to that digital twin is in essence a cyber physical system. And so the makings of the digital twin are quite simple. You need your physical objects, you need to model that in a virtual environment, and then you need to have some type of sensors to give you those data streams. That could be IoT, or that could be IoT, that can be scheduling. It doesn't matter as long as you have those real-time data feeds back in there, right? And so what you have with those three, without all those three, you get all the other information, right? So a virtual environment with a physical object without the sensors, your typical BIM model. If you have your physical object with sensors, you definitely have either IoT or your information intelligent transportation systems. If you have sensors within a virtual environment without digital twin, that's when you get more of the virtual reality. And so the digital twin, the heart of that is the encompassing of those integration in three. And with that, you have that continuous data synchronizations. Now you can go into the nuances is how often does real time mean? Is it in milliseconds? Is it minutes? Is it data? That question isn't really necessarily a major issue. It's the fact that you get that real time data to make those updates. And with that, you have predictive and prescriptive analytics. And then the heart of it is this physical feedback loop, which makes it into that cyber infrastructure. And without that, you don't have that true meaning of the digital twin that you can learn from, right? And so just kind of brief overview of how this works is you have your physical world, you have your assets, you have some sensor data, you have information that brings it into the virtual. It does its thing. You put your thresholds in there, you get the updates through the AI, and the key aspect is now that information sends back. You can make decisions and you can make actions. That is a key defining factor that you can make actions based on your virtual model. All right, so in transportation infrastructure trend is pretty much what we've been working on the past few years, focusing mainly on the BIM, but on the bridge side of things, but it's still the same strip, right? So we have the different sensor models, whether it's video, structural health monitoring, way of motion, but then we can add traffic data, environmental data. We have the ellipses over here in top right, meaning the list continues as long as you get that information in there. Now, one misconception about a digital twin is a 3D model, right? A 3D model is one aspect. It brings that information of the geometry with the object data and processes. That is what we typically call the BIM model or the CAD drawings. Without that sensor data, without that real-time input, you don't typically have that digital twin. And now on top of digital twin, you have your AI machines and then analytics software to do that. And collectively, you now can do your real-time monitoring, your predictive analysis, optimization, and decision making. So even though getting to that real-time full data immersion is something of futuristic interest, we may not have to be there. We may not be there now, or we may not have to be there in the future. It all depends on what you need, and we'll get to that. But essentially, there's a maturity level index that was adopted by previous research, right? It started with the basic 2D drawings from papers to from paper models to computer-aided design, and moved up to your 2D 3 BIM models, and then we added those to collaboration insights. Then we get into the web base for the building lifecycle management, and then throw some sensors on top of that, and then you get your digital twin. But even if you have that, you can even go further with the AI and for your predictive analysis and optimization. And again, depending on your use case, depending on what you need for that, you can be up and down this model, this maturity level. But the end goal, right, is trying to be this Tony Stark. Let's be able to be immersed within our data so we can get those real insights. All right, and some life cycle benefits, it goes throughout the entire, from designing to planning. Right, so for planning design, that's your typical BIM model with you doing your de-risk simulation alternative. You have your de-risk decisions. Go to build, typical coordinated trays, detecting clashes, monitoring progress and quality. And then for the operation, it's where it starts kicking in, where you can start predicting failures. You can optimize your assets, right? If you have that limited budget, which asset should we put that to, right? Based on that information. And finally, we can add to with the adapt and resilience, respond to the disruptions in the environment and plan for these climate adaptations. And what's the benefit, again, with that feedback loop, all that sends that information to future designs. So you can go back to the insights. So when you go back to your planning of your new asset within your digital twin framework, you can now take that data, simulate the what if scenarios, and you continue this process throughout the duration of the life cycle and future projects. So moving on, I'm going to show you some global showcases. Like I said, digital twin, it's been around for a while now. These are just kind of a snapshot in time. I'm not promoting them. I'm not saying more information. I'm just kind of highlighting that these are some use cases that you can further go into. I'm no means any expert on these. I just went through, read some papers, read some of them, and thought they were pretty useful to show some of the benefits. So the first one is the Helsinki 3D Open Twin. It's all about utilizing data for making decisions, right? So their mission is to make city decisions more transparent and data-driven with an open, continuous data twin. All right, so I went to the geospatial, and you can actually see some really interesting assets when you go into that. All right, so highlighting, it uses the mesh system with CityGML. It has the open data sets for developers, and that key open data is important for these digital twin developments. And then you can apply retrofits, noise mapping, visibility shadows, zoning analysis. And it's all layered on your aerial imaging and LiDAR. All right, next is the Port of Rotterdam. And their mission is to build a live port with port-wide digital twin to run safer, smarter, low-emission port than to pave the way for autonomous navigation in 2023. But some of these highlights is there's a live port-wide twin. It's for cleaner operations and future autonomous navigation. It has just-in-time sailing with their geo-reference triggers, so you can see what's coming up down the river, literally upstream. And then they have some global sustainability issues where they had this Vital and Volpac pilot where they're trying to utilize a reduction of the 20% of CO2, right? And then top of that, you have different alerts, you have your grid energy, pilot shift loads, depending on infrastructure. So energy infrastructure is going to be an important use of digital twins. And then it's made to have a test bed for future startups. Virtual Singapore is, again, about open data. Their mission is to see a shared authoritative, semantically rich model of the city to test policies and infrastructures before they're built. So it's, combines the high detail 3D models and IoT land usage. It's used for the shade solar potential wind flow evacuation. It enables cross-agency data sharing and citizens. So when I went through this, I was able to make a map on UAV drone flights. So if you go there, you can pick any of the citation or the filters you want to see, and it actually gets in there. Right. Another one is about shade. If I want to do go do some commuting, or if I do new development for weather, you can embed that weather forecast within your model planning. In airports in Amsterdam, this is more of a asset and twins operation, or asset and operations twin. And so their mission is to run a safer, more reliable airport by forecasting the operation impacts before there, right? So we're talking about the users, the pedestrians, the people that come through in and out. And so they integrate the traditional BIM, which is the facility, with the GIS of the Air Force and the live operations into decisions environments, right? And so with all these major airports coming in there, they're going to be more passengers, bigger. So they always have to forecast ahead of what if scenarios, right? So they simulate construction closures, passenger flows, and turnaround impacts for those optimal windows, right? And also improves their wayfinding within the airport. So I don't know if you ever tried some of these internationals, they get pretty extensively large. That's difficult. So having that real-time model can help with that wayfinding. And again, it has a shared view across the airports, airlines, contractors, and webinars. And finally, last global is the Cross River Rail in Brisbane. It's a mega project twin, and that mission is to deliver a complex new rail link with fewer surprises and clearer stakeholders' understanding. Right, with many infrastructure projects, stakeholder buy-in is important. Right, they want to make sure the public is their needs are addressed, their needs are concerns are met, so they can go ahead and have a publicly usable product. Right, and so this one, the highlights is important because portion of it is within the as a subway, right? And so it spans tunnels, stations, rail systems, and above city ground context. And what's neat about this is you actually have a 4D VR walkthrough that you can go through and see pedestrians coming in, see some of those clashes, and so we can bring up those for that community stakeholder engagement. So there's always live links and updates to accelerate coordinate times, and extends into operations for asset and maintenance when this project gets complete. But fair enough, we don't have to look too far across the globe for some of these digital twins. There's a lot going on within the U.S. themselves. All right, a major one with the shipping is the Port of Corpus Christi. They have their optics active port digital twin. And the whole goal and mission is to have the one pane of glass for real-time situation awareness and emergency readiness, right? Given the historical past with the Baltimore Bridge collapse, or Baltimore Bridge collapse, shipping is a dangerous and economically impactful industry, and so that too is important to have some of these digital twins, right? And so they're focusing more on the safety aspect of this. So they pair with the Unity and ArcGIS. It fuses their automatic identification systems for the vessel tracks. It also includes weather, IoT sensors, and targeting specifically on safety, their police computer-aided dispatch system. So if there's something that's about to go awry, they have straight communication with their emergency response, right? And part of that is they also use that for generated AI emergency training with scenarios. Up in Tennessee, we have the I-24 Motion. This one's focusing on creating a live research-grade freeway twin for city traffic and connected autonomous vehicle behaviors. right? Some of the highlights, it has over 300 4K cameras capturing the vehicle trajectories. It's in partnership with the Tennessee DOT is with Vanderbilt to evaluate the traffic management and AV tech and real traffic. So they have really really good AI algorithms, and I had the numbers. I forgot to put them in there. I think they're up within like a deviation of 2 to 5% of what that would be, which is pretty impressive. And one of the biggest aspects of this is everything that they're doing is open. So you can go to their GitHub, I click below and get the code, get the data repositories. But again, it's all about open data sharing and making improvements collectively as communities. Next in Washington, we have the I-90 Homer Hadley floating bridge. All right, this mission is to instrument the floating bridge to create a digital twin that tracks performance, as well as a link light rail coming up. Right, so they're about to add a light rail system across the bridge. So just a fun fact: Washington has the highest amount of floating bridges out there. So if you're landlocked in state, you may not have many floating bridges at all. I've ever even heard that, but it's actually a pretty sophisticated feat. And so their University of Washington Mobility Innovation Center is deploying the IoT sensors to measure the load responses to validate the operations. It is based on the anchor cable forces, lateral movements, and alerts. So if there's waves or the pontoon gets too high or moves that threshold, they'll get those real-time alerts as well. All right. And also important for this, it actually guides for the seasonal retentioning, right? Those, with all the tension and torsion that goes on those cables, they need to go out for the yearly maintenance. And so having that predictive analysis can schedule that at the optimal time to conduct the maintenance without failure and without preventing backups in busy seasons. Right, and they did a substantial ROI on this, and back in 2022, placement of eight cables cost about $9 million. Now, if you can extend that life, they came up with the ROI of 2,000%. So that's pretty amazing. And finally, I can't leave out our work here at University of Florida, and so again, we're data. We're trying to go more on the interoperability side of how do we take these open IoT sensors, do these open protocols, and commute with that, right? So IoT is huge. There's hundreds of protocols on the industry, and there's many organizations to the point that there really is no one proper way to do that. And without that one proper way to do that, you're not going to have a lot of interaction with cross units. So that's one of the major tackles that we have been working on. So to test some of our thresholds, we developed this digital bridge to a concept. Whole idea is to mock a sensor, use open data to go ahead and create that. Right. Again, it's back to what a visual twin is. It's a physical model with the sensors. You have your virtual BIM model, and then you get that real-time network feedback. Right. And so how we're doing this is, when we get the live loading, and this we use a WIM sensor, just a simple concept to predict when that load can failure. And so throwing it through our sensor data, we embedded thresholds, at the what if scenarios, and based on the loading of the bridge, you'll get a real-time alert, or you can get that vehicle pass. Similarly, how the way motion sensors work on the highways, we can now embed that system in advancement with the bridge, have that bridge structural health monitoring sensors updated for that predictive analytics. Okay. And so now getting into the advanced capabilities. Predictive analytics, that is going to be one of the most important concepts, especially with our aging infrastructure. And so there's studies out there about using these AI models for bridge condition ratings, right? And so the current models without AI at roughly 79, but utilizing that AI gets it up to 90%. And if you start getting into the real-time data, I hypothesize that we can get up to 95, 98% when we start doing this whole data immersion. And that's going to be key with what we get out there. All right. And there's also a lot of work on imagery and photogrammetry. And so there's one about pavement cognitive digital twin that you use neural nets to detect the defects early and trend deterioration. So again, for that predictive analysis of scheduling out there. And then there are a lot of studies regarding structural health monitoring. digital twins. So you have the distributed sensing and model update for those predictive structural responses. Prescriptive maintenance. So now utilizing what we're going to prevent catastrophe. Again, structural health monitoring is a major area of research. So utilizing the calibrated digital twin with structural live data. One study had those predictive responses within 5% deviation, which is essentially 95% accuracy using that live data. And then it's also bridge maintenance systems that integrates the life cycle for damage repair history and recommended actions. There's driven preventive maintenance strategies. So how do you use past data for planning? How do you incorporate traffic, climate, services? And then finally, again, with that decision making, how do we look at not just an infrastructure, but actually as a city area at that network level at home? And so there's framework for those time target retrofits and budgets. So decision making and what ifs, right? So there's connected corridors that simulates traffic controls. There's vehicle to cloud, so for the connected automated vehicles for testing. Like there are urban and air ground, right? So there are actually digital twins based on drones, which is pretty a neat study to read, that utilizing the future of drones and how that's going to happen with hazard anticipation, and then overall infrastructure, and then finally operating those on a special base rules, so you can get those what if scenarios. And so now is, how do we get there, right? And this is purely on a technical approach based on what we know in the use cases, right? It's very important to define your scope and objective, right? And one of the key aspects that we found reviewing these studies is you may not need a whole digital twin. You may not need a immersive. If you just want to do surface task, right, in the fun details, you can get that. If we have the budget of Tony Stark, which that would be amazing, then we can get that beautiful digital twin. But we may not have to ever get there, and that's okay. But we still need to identify who the customers are, who are the stakeholders within the organizational goals. How are we going to share data? One of the current projects I'm working on at Ohio, the Department of Transportation, is how do we share data across departments within FDOT so we can develop these twins? And that's a key factor, right? If your organization doesn't have the capacity to share data within themselves, how are they going to share the data across the life cycle of that facility, right? And so it's smart, start small with use cases and maintenance. And one of the other defining scopes is, knowledge base on AI and these tools and technologies. Right. And that's another consideration when we start to define these scopes, right? And then, next is to focus on data foundations. What are available interoperability standards? We're well known with IFC, linked data, semantics. There's a lot of IoT open protocols out there. How do we understand getting our data to the cloud, right? It's very data heavy. What are cloud resources? And if we want to get into AI, machine learning, what high performance computing do we need? Then we look into what type of data are we looking to capture. And once we understand what data we need, then we can look into what are the different sensors of connectivity, right? So if we're going to deploy those systems, we need to have that reliable streaming, right? Construction environment, remote environment is a very challenging aspect for real time. So how do we ensure that we have enough coverage, and whether it's power, connectivity, to get those tools working, right? And finally, AI or machine analytics that I can use today, right? We are in a huge AI boom. Things are coming fast, and they're going to keep coming for the next few years. And so there's a lot of good tools out there. There's a lot of training out there of how to use this, right? Students these days, I've never seen a student come in with the resume without some type of knowledge within AI or computer analytics, right? And so with that, you're going to move from your descriptive to your predictive, all your to your prescriptive insights. And finally, another key that we haven't touched on just yet is the governance and security, right? Data, right? Personal data, private data, secure data. So how do we ensure policies for that? Who owns the data? That's a huge challenge today, even without digital twin, with just general contracts. Right? Who's that data? If we generate this data, is it a liability aspect of it? And then finally, the cybersecurity. How do you build your base? What do we have for cybersecurity to make that data secure? With also that governance is how do you build your base case with that ROI, with your value to your stakeholders? And finally, once we get that idea is how do we train our workers? How do we get our staff in our firms to understand what this is? All right, that's another challenge to get into, is the training, cultural shift to embrace this. And finally, once we get that, we can start working on your pilot scale to integration protocols. And so we can get there now. There's a lot of cool stuff out there, but there's a lot of risk involved, right? One that we identified is the full integration, right? I mentioned this before. Do we even need a full digital twin? All right, we have all this sensor, all these data, they're massive. It's hard to share. Right? A lot of firms have what we call vendor lock-in, where they have these their specific licenses that may not have the capabilities. Right? Sensor compatibility, data formats, there's hundreds of them out there. How do we ensure that we can have that heterogeneous platform of data? Right? Even with that is our current systems. How do we go from our legacy versions to new and manual automated outputs? Sensing themselves is, again, connectivity and remote sensing, talk about that. Data collection burdens, right? So even if we get the data, how do we ensure the quality, right? So the noisy records issues of getting there, sense durability, data interoperability. I've already touched base on important data is key. But if you can't get your data, if you can't get reliable data, then you're going to have some major issues. And finally, getting into this high computing aspect are those performance computing resources, right? So how do we, what's the computing power do we need for specific use cases? How do we get access to high performance at a reasonable cost? Right? Technology issues are, it's just time-based. Put the effort in, put the knowledge base, and you start getting tangible solutions. But on the flip side, we go more to organization and governance. And regardless of how well that technology is, if we're ready today to say, I have a digital twin ready to go, we're going to still run into issues. And it's all based on the people and processes. All right. So, the sensitivity, privacy of data, people may not want to share their information. People might want to give up their assets information for this information. Right. And then there's governments, not just that they don't want to, they may not be legally allowed. Right. If we have a tool that's built in, outside the United States, are we able to share our data out there? Right. And then current systems, over the years, people are trying to invest all these new technologies, spending hundreds of tens of thousands of dollars on these systems. Why would they pay more for a new system if they already have systems that may work? Right. And so you might get in some prevention of that. Right. Cost effectiveness. Right. The studies have shown the long-term ROI, but again, there's high upfront fronts. Now, not only is it the hardware and software, but it's the training, it's the skills, it's the getting people to adopt the technology is going to be an issue. All right. And then that goes into the skills and workforces. Right. We have a shortage of digital twin AI experts in the field today that know the day-to-day basis of infrastructure. We're, fortunately, are in a culture of AI that we're training students to graduate with AI, but they may not necessarily have those skills of the infrastructure. So how do we reach that gap between the software experts with the industry experts? Right. And so, you'll see a lot of this, of the cultural resistance change. People today in the workforce, they don't want to be told what to do because what they do works. And so, in wrapping up, it's key takeaways, right? Digital twin is basically a physical object with your virtual model and your sensors with that data streams. That feedback loop in turn provides data that takes your actions and monitoring and makes them into actions and responses. It's important to know, even though it might not be techie or standard, it's okay. Just don't get bogged down on the vernacular, the nuances. Do I have a digital twin? Do I not? And the technology. Do I need this technology? Do I need that technology? It doesn't matter. Digital twin is the evolution of BIM. It's a process. There's varying level of technology based on your use case needs, right? It's all about the data. You might not even need the full digital twin. As long as you get that data, that's all you really need for your final projects. Focus on purpose-built twins, right? Those are the ones that are going to be most productive. Instead of wasting all your time and efforts developing a pretty picture, if you are focused, you know exactly what you need, you can spend costs, all your resources to get that, and it's going to be the best bet of the models. Through as a company, use your index to move from your BIM to full cyber physical system when you get there. And again, you may not be utilizing that full eye based on your ROI. Again, governance security are must-haves, right? between the privacy, your authorization of data, your data compliance, workforce readiness, and driving adoption is going to be key. Studies have shown the ROI is tangible, especially if you have your targeted use cases. You know what instruments and analytical software you're going to work that can actually defer the major costs and reduce downtime. And then finally is how to build your AI capacity, right? We hear a lot of talk in there that the AI is going to drive away the workforce, which is true in some sense, and that's because it's based on the data that can be read. If you can read a document, then AI will take it over. If you can write a document, then AI take on more. But what AI will struggle with is getting that data. If AI doesn't have the data to act upon, it's not going to matter. If we don't have the IoT sensors to provide those real insights, AI is not going to matter. So it's all part. There's always going to need staff. There's always be someone to develop these sensors, to monitor the systems, to adopt the AI and make it so it could be a tool versus a replacement. Right. And so there's a lot of ways of getting there, whether you partner with institutions, partner with industry organizations, hire consultants. There's a lot of ways that, if you're not an AI firm today, you can start leveraging AI right away. To take out, how do you get involved? Right. There's a lot of industry out there. The list I show right here are just the ones that I vetted. I'm part of. There's a lot more out there with AI. Many universities and so wherever state you're looking, if you're an industry practitioner, look at your nearest university. There's going to be some type of AI or digital twin out there. Look at your local industries. All right, so TRB just recently reformatted with their structuring committees. I'm not sure of the final output yet, but digital twin is one of the themes. The National Institute of Building Sciences, they're going with a whole total revamp of no longer focusing on the BIM council, but more of this digital technology, right? We're no longer at the 3D or the 2D, 3D paper-based BIM model. We're now moving for digital delivery, how to get our data to the field. And so with that, they restructure their committees into the digital delivery, field technology, and digital twin, which all three of those will have some impact and user need. And then likewise, you have the AIC committee. They have the different communities. Even though there's not technically a digital twin community just yet, you have the computer systems, resiliency committee that all have touch base on some of these dates. Right. Building Smart is a major IFC, is major industry standard for IFC. And then finally, can't leave out the digital twin consortium that is kind of like the master of all this type of digital twin work. So with that, as promised, I'm going to leave 15 minutes for questions and answers. All the citations throughout this lecture are in these two recently publications we have. If I didn't already embed the links to those use cases. So with that, I will pass it back to Tu Yen and open up for questions and answers.
All right, thank you, Aaron. All right, so if anyone has any question, please feel free to unmute yourself and ask the question to Aaron. You can also type your questions in the chat if you like.
Yeah, I'm going to stop sharing my screen so I can talk to the people who's asking the question, and I'll bring back the presentation if we need to refer back to it.
Well, I'm just going to ask a quick question. Again, we talk all the time about this issue we have. What do you think, if there's anything, the government could possibly do, or they should or shouldn't do to encourage this adoption of digital twins, AI, etc., in construction industry? Do you feel like the government should or can play any role?
Oh, definitely. And the government recently has been a driving force with this, right? With the infrastructure bill that came out a few years ago, then they had the AI legislation that came out. It's their digital twin is out there. There's NSF, National Science Foundation, has a lot of calls with the cyber infrastructure. We term digital in our industry. really that's that cyber physical infrastructure. And there's a lot of research out to how to implement that. In terms of the organizational, NIBS sees this, so they're focusing on digital twin. They just wrote that white paper about positing how to get to the next level. And again, if you're not familiar with NIBS, is they're an industry-run organization, a non-for-profit trying to develop these solutions for use within the industry. All right, and right, it was a Congress-appointed organization, and so they're there to serve the health environment. All right, and so they're pushing out there. They're working with they have a couple projects on there looking at digital twin and open standards data for that. And then FlipFly's TRV, right? The Transportation Research Board that we're talking about general infrastructure, but my research is mainly on the transportation side. But that going there, that's a huge topic. AI is going to be a huge topic now. So they're always looking for research, and they have the different funding mechanisms from NCHRP through the pool fund studies with the DOTs. Now, the one benefit from the transportation side is they're a few years behind the vertical side. And so it's almost like, I'm not going to take this, a colleague of mine said this, it's almost like I get to do BIM again. And it's going to be exciting because we could do BIM well. And so, yeah, there's a lot of opportunities to get it there and to start making contributions. And the best way, based on my experience, is you can't do this by yourself. As a student, I've always tried to make the best, make one thing, a project. I have a cool tool, cool technology. I say it's going to work, it's going to publish on it, but that's really not how you have action. You have action by cooperating with other universities, working with these centers that already have established partnerships with the DOTs and industry. So if you're a student looking on here, a PhD student, postdoc, look towards your university, see what resources you have to start engaging with these type of resources. And then all those links, I know they're always looking for more volunteers and insights, right? So if you have a good idea, the only way we're going to move as an industry is being the voices of the industry. So we can't assume someone else is going to do that, because that in reality they're not. We have to all collectively participate.
Okay, thank you. And I've also posted a few links to those who are interested in getting involved with the Digital Project Delivery Committee, keeping up to date with our activities in LinkedIn page, or attending the CRC-CI Summit next year, and the committee page at ASC website. So feel free to browse those links and get in touch with us. And I think there's a question on the chat, so I'll let you take it.
So in regards to beginning our framework for digital delivery, what are some great examples for maturity of level development as project moves from designation, design, construction, and maintenance? There's a major project. I think it's a pool stump footing, looking at to not only the development, but the level of information needs, right? Before we can start even embedding these uses in a technology, we have to understand what we're trying to achieve. And to achieve that, we need to know information. And from that information is where we can start collecting our data. So maturity levels, I don't have any off the ring of my bell. One of the citations I have in my paper that talks about where the original BIM maturity level came from, that went up to the BIM level. So they might have some of that level of development in there. Does that answer your questions, Seth?
Yeah, I was just curious if maybe like there was another agency that may already have some of this documented for their digital delivery, because I know there's other projects that are being delivered. I don't think it was Pennsylvania. I'd have to find out, but they actually did a full project digital delivery. The model was the legal document, and I was just curious, out of that, if there's some good documentation that we can read or refer to as we kind of define, like from like design to construction, because like even just our design, they have multiple phases through their workflow that, they don't need all the information at the very beginning, and they define it as they go.
Right. Okay. So that's more of the information needs. There are two pool fund studies that, they're not, like I said, transportation is a little behind in digital twin. But these pool fund studies are looking into how to develop the roadmap for integrating model-based delivery. So the first one I dropped was BIM for infrastructure, and they have a suite of documents that look at modeling as a documentation, as legal development. PennDOT's been one of the leading ones, UDOT. And there's actually a literature review. I helped with that project. I'm doing a literature review of getting some of those needs. And then the BIM for bridges. The second one is the BIM for bridges pool fund, where they're starting to find the information delivery manuals and the model view definitions within the IFC schema to get this, right? So the first phase of BIM for bridges was developing the data needs for design extraction. And then the next phase, that is year 2, that's ongoing, is now focusing on construction and fabrication and getting into those assets. So these are two major resources that I know on the back of my mind to get to without having to go back to literature review.
Hey, Aaron, I think I have a link to Utah DOT. They already developed kind of like strategic plans. I'm adding the links to the chat for everyone to check. So that's linked to Utah DOT. So they pretty active in like adopting digital twins. So
Mhm.
you guys can find some helpful information there.
And I think New York DOT is one of the first ones to actually use BIM models as a contract document, not just provide it as an additional information, FYI information, but actually use it in contracting. I think Georgia DOT is doing something similar now, I think. But those are a couple things that comes to my mind as well.
Yeah, and there's another publication I was working with Nibs on that we just submitted for final approval that should be published next week about a centralized BIM transportation library of what data is out there, how can we use a centralized repository for our data informations. And I do remember going over some of those deliveries, what state DOTs are doing. So once that's published, that will give you some more references to read into.
All right. Is any other questions for Aaron?
Yeah, so free. I will drop my LinkedIn contact, so feel free to reach out. I'm always happy to share information
Mhm.
to help out. Copy that. So just drop me a note and be happy to connect.
Like Aaron, just quick question. What do you think what type of assets would benefit the most from digital twins?
That's a good question. That's a tough question. And it's the ambiguous answer. It depends.
Mhm.
But if you look at, and this is just from my experience from traveling, working with the Transportation Research Board, all these committees, the biggest need that I hear from stakeholders is I have so much data, I don't know what to do with it. And so if there are ways of mechanizing, using AI machine learning to kind of help make that data utilized, right? And so for the DOT aspect of things, that's typically their assets. Like how do I maintain their information? But looking at like the built environment, you have your construction data, you have your your real-time input, real-time progress monitoring report. So going based on that use case and where would digital twins best be used, it all depends on who needs it. So it's good. Again, I can't stress enough, you may not need that full immersion of data for that cyber infrastructure system. That is a great goal. That is something that will be very useful in 10, 20 years when we need, universal planning, right? Citywide urban planning, right? So that might be useful for them. But when you're, a contractor, you might just want to do the BIM model, having updating schedules, sequencing trades, making sure that your work's in there. and even autonomous, right? We're experiencing an exasperated labor shortage now, right? How do we ensure that what we're building is being built and to be built to quality? And so we're going to see some better quality assurance type, I don't want to say twins, but technologies that will go out there, whether it's digital imaging, videos, IoT sensors. That is where the next realm within the industry is going to be, both in the construction of the assets and the operation and maintenance of those.
Okay. All right. Thanks. All right. Is any last question for Aaron? So he already added the link to his LinkedIn account to chat. So if you interested in the topic and want to learn more about the topic, so feel free to reach out to him. All right.
And then the slides, I'll send you the final slides. You can have the post, and then whatever you post the webinar.
Cool. Okay. Before you leave, I just have a quick request. So I'm gonna pull up this survey. I'd just like to know whether you're interested in like knowing about future webinars, so I can get your contact and we will send you information about future webinars. Okay, I'm gonna leave it there for a few more seconds and then I'll close it. All right, I'm getting more responses, so I'm gonna end the poll now. All right, thank you for responding to the survey. All right, thank you, Aaron. We are extremely grateful to your contribution to the community, to this particular area. And we look forward to working with you in the future.
Okay. Bye, everyone.
Thank y'all very much.
All right, have a good weekend, everyone.
Thanks, everybody.